this is 7.4. What you'll notice in 7.4 as we move along is that we are still talking about intervals. So your answer is still going to have a lower bound and an upper bound. And we are still going back to one sample. And so you're going to have data set number one, and that's it. You're just dealing with one data set right now. But here is the change. Instead of working with the mean and standard deviation of a data set, we are now working with a proportion, or you could almost think of it like a probability. We're going to be working with P's and Q's, the probability or the proportion of success and the probability or the proportion of failure. And so this is something that should be a little bit familiar. Here is our main variable, and this is called P hat. So it's kind of like this, the letter P has this little hat on it. And so we call it P hat. That's the term that we're going to use. And this is the ratio, proportion, or probability of success. That's P hat. And also, you may know this, once you have P hat, you immediately also know Q hat, because Q hat is just P hat subtracted from 1. It's the complement. So if you know that P hat is equal to 30%, you immediately know that Q hat is equal to 70%, right? If there's a 30% chance of it raining, then there's a 70% chance of it not raining. These are complementary ideas. Okay, so we're going to take this P, we're going to take Q, we're going to throw them into some magical equation, and out is going to pop our friend, the margin of error. And you're going to take that margin of error and you're going to add and subtract it from P hat, this new character that we got, right? So instead of adding and subtracting from the mean, which we did previously, we're going to add and subtract this margin of error from P hat. So again, kind of the same idea. You're going to have P hat here in the middle, and then you're going to add the margin of error to get your upper boundary, and then you're going to subtract the margin of error to get your lower boundary. And we've played this game before. You've seen this. So the question is, how do we calculate the margin of error? That is really the only difference in this situation. And here is how you calculate your margin of error, right here. And so these are some characters that you've just been introduced to, but it feels like they're familiar friends already. You know what P hat is, you know what Q hat is, you know what N is, it's the number of items that we have. And here is our old friend. Yes, we're returning to the z-score, okay? So we could use a t-score in this situation, but we're just gonna go with the z-score. And here actually is how that z-score is calculated. You have to do some, and again, this is gonna be done for you in the spreadsheet, but you're going to have to do some sort of P hat minus the original probability divided by the square root of all this kind of stuff. That this value here is Q hat, but don't worry about all of the components of this. I mean, or, you know, the arithmetic behind it. Just understand that we're going back to the z-score, and then we're going to multiply that by P hat, Q hat divided by N square rooted, and that will give us our margin of error. Once we have that margin of error, we are going to add and subtract it to P hat, and that will give us our interval. So we're going to add and subtract the margin of error to P hat to get our interval. In example 2, we're talking about the difference between low-income countries and high-income countries and the number of infants that are fed formula when they first are born. How many are fed formula? So in Germany, which is considered a high-income country, 22% of all babies are fed formula. So that's sort of the established 22% is our original proportion of success, we'll say 22%. So if you wanted to, you could say from here, P sub 0 equals 0.22. Okay, that would be our original probability of success. And now what we're going to do is we're going to compare that with data from a low income country. So you go out and you do a random sample, 500 new mothers, you find that 125 feed their infants formula. So from this information, we can determine that P hat is equal to 125 over 500, which is 0.25. What we're going to do is now determine a 90% confidence interval that the proportion of mothers in low-income countries fed their infants formula. That's what we want to find. What is the 90% confidence interval that we're going to find with this? So here we go. This is what we're going to do. So we go down here, n is equal to this, p hat is equal to this. This is what we just calculated. The confidence level is 90%. So our z-score is 1.645. Again, this is, you could look this up in a table, but we're not going to. We're going to use a Google Sheet formula to look this up. Norms INV is the formula that we'll find in the Google Sheet formula to look this up. And so we take all of this and we put it into that Google Sheet. There's our margin of error. We then take p hat right here and right here. And we're going to subtract the margin of error to find our lower bound. We're going to add the margin of error to find our upper bound. And so here is our answer. So this is basically 21.81% up through 28.19%. So we can be 90% confident that if you surveyed all of the low income countries, that the proportion of mothers that fed their infants formula would be between 21.8% and 28.19%. So again, if you had 21.8 all the way through 28.2, we'll do some rounding. Let me draw it this way. Boop, that's better. We are 90% confident that if you were to survey all low-income countries, the average number of mothers that fed their infants formula would lie within this range. Now, could there be countries that lie outside this range? Sure, 100% there could, well, not 100%, but 5% on this side and 5% on this side. We could be wrong. The average could be above or it could be below, but we're 90% confident that it's in between these two intervals. You'll notice that this spreadsheet for 7.4 is actually pretty simple. You only have 3 inputs. You have the number of successes, the total number of items. That will calculate p hat and q hat. And then once you have that, you just put in your confidence interval. So for problem number 1, n is equal to 460. So there's 460 items in my survey. So I'll put that in here, 460. And p hat is 0.54. So in this problem, they're giving me p hat. They're not giving me the number of successes. So I actually got to figure this out. What number of successes would I need? What numerator out of 460 would give me a p hat value of 0.54? Basically, what is 54% of 460? So I could figure this out maybe with a calculator. So I could say 0.54 times 460. And I get 248.4. And if I put that number in here, notice my p hat is 0.54. My q hat, which is just the complement, is 0.46. So I got 248.4 as my number of successes, divided by 460 gives me a p hat of this. It gives me a q hat of this. And now all I need to do is punch in my confidence interval, 0.90, my confidence level, confidence level, 0.90. The spreadsheet calculates my z-score based on the confidence level. It calculates my margin of error based on the formula that we showed you in the textbook. And then it calculates my lower boundary and my upper boundary. So all I got to do is copy this margin of error and paste it in there. Round it to 3 decimal places. 1, 2, 3. There we go. And we should be good. This is question number 9. This is a good one. So you recently sent out a survey to determine if the percentage of adults who use social media has changed from 56%. So you're saying that sort of the baseline, the original value, the population is 56%. Of the 2,685 people who responded, 1,640 stated that they currently use social media. Okay, so these are my values for N. So 2685 is the total number of people surveyed, and the number of successes would be 1640. That will give me P hat, and it will also give me Q. So right away, you can see that the current proportion, the current percentage is 61.08%. 61%. And remember, before it was here, 5 years ago, it was at 56%. So now we need to construct a 91% confidence interval. So I'm going to go to my confidence box. I'm going to put in 0.91. Here's my z-score. Here's my margin of error. And here is the interval. So I'm going to copy and paste that, enter a comma, copy and paste this. And then I'm going to put parentheses around the whole thing. Round to 4 decimal places. Okay, I think we can do that. So there's 4 decimal places there, and there are 4 decimal places there. So we, again, to summarize this, if we kind of built a summary, we'll put those in there. So we got 59.48% as our lower bound. We got 62.68% as our upper bound. So we are 91% confident that from our sample, if we were to take the numbers from our sample and project it out, we would say that today we are 91% confident that the number of adults that use social media is in between these two values, somewhere in here. We're not quite sure where, but we're 91% confident that if you were to survey all adults, the entire population, that the ratio of adults that use social media is within that interval. And we're 91% confident. Now, if you wanted to be more confident, if you wanted to kick this up to 95% confident, that's going to increase your interval. And we could show that by going, once again, into the spreadsheet. We could change this to 0.95, and now our interval increased. And we could change it to 0.99. And the interval increased again. It got wider. Our margin of error got wider. And so kind of a good idea to understand what's happening there. But that's what this says. Okay, so we established the interval. We got that. Okay, let's see. Can you conclude that the percentage of adults who use social media has changed? Well, we were at originally, this is 59%, right? This number here is 59. I just want to be clear on that. So let's put this at 56%. And this was 5 years ago. So 5 years ago, we were at 56%. And this is the interval from today. So can we conclude that the percentage of adults who use social media has changed? Yeah, I think we could. Yes, because the proportion of adults who use social media 5 years ago is inside the confidence interval. No, it's not. Yes, because the proportion of adults who use social media 5 years ago is not inside the confidence interval. Bingo, that's the one that we want. Proportion of adults from 5 years ago is not inside our confidence interval. Therefore, we can say that the percentage of adults who use social media has changed. And then finally, if it has changed, oh yes, it has it increased or decreased? I would say that the percentage has increased. It went from 56 5 years ago up to this interval today. So I'd say that the percentage has increased. Submit, and we got them correct. Again, this is something where you want to be able to draw a little picture, just take an envelope, and on the back of your envelope, sketch this up and understand, okay, here's my interval. This is where it was 5 years ago. This is my current interval where I'm 91%. Is it within that interval? And what does that mean? Has it changed or has it not changed?